This is the EdExcel GCSE 9-1 Maths Foundation Paper 3, which is a calculator paper and it's from the 2022 series. Question number 1. We have to write 35% as a fraction. 35%, that means we have 35 out of 100. So, we can simplify this fraction, dividing the top and bottom by 5. We end up with 7 over 20. So we have 7 over 20. Question number 2. We have to work out 1/4 of 28. Well, if we have 28 and we are working out 1/4 of that, that is the same as dividing 28 by 4. And it turns out we get 7. Question number 3. We have to write down 2 factors of 12. We need 2 numbers which multiply to give 12. 1 times 12 gives 12. 2 times 6 gives 12. 3 times 4 gives 12. Here are the factors of 12. We need to choose 2 of them. For example, we could have the 3 and the 4. Question number 4. We have to simplify 2m multiplied by 3. What we will end up with is 6m. 2 times 3 gives a 6. We are still multiplying that by m. We end up with 6m. Question number 5. We have to find the square root of 1.69. If we type into our calculator the square root of 1.69, we end up with 1.3. So we have 1.3. Question number 6. On the grid we have to draw a quadrilateral with no lines of symmetry and rotational symmetry of order 2. Well, what we could have is a parallelogram that's not a rectangle or a rhombus, such as the one we see here. Now if I attempt to rotate this, we can see it's got 1, 2 for the rotation order of symmetry. And we also have 0 lines of symmetry. Question number 7. The table shows the total number of apples sold and the total number of oranges sold in a shop in each of 3 weeks. So we've got number of apples and number of oranges. In total for the 3 weeks, more apples than oranges were sold. How many more? Well, what we can do is find out the total number of apples. That's equal to 86 plus 75 plus 92, and if we work out what this is, we get 253. Now if we work out the total number of oranges, we have 68 plus 80 plus 76, and it turns out we get 224. And so therefore, to find out how many more apples than oranges were sold, we need to find the difference between 253 and 224. And if we work this out, it turns out we get 29. Question number 8. Here are the first 5 terms of a number sequence. We've got 3, 8, 13, 18 and 23. And what we have to do for part A is write down the next 2 terms of the sequence. Well, do you notice each time to go from one term to the next, we add 5. So to find the next term, I need to add 5 to 23, and it turns out we get 28. And then we need to add 5 once again to get 33. Here are the next two terms of the sequence. Now Jim says that 50 is a term in this sequence. Jim is wrong, we have to explain why. Well, all the terms in the sequence end in 3 or 8, which is why 50 is not a term in this sequence. Question number 9. The diagram shows a solid triangular prism, and for part A we have to write down the number of faces in the prism. Well, we've got one at the front, one at the back, then we've got this side, then we've got this side, and then we've got the bottom. We've got 1, 2, 3, 4, 5. We have 5 faces of this prism. Then we have to write down the number of edges of this prism. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 edges of this prism. Question number 10. Here is a list of 8 numbers, and Kim picks at random one of these numbers. On the probability scale below, we have to mark with a cross the probability that Kim picks a number 7. Well, we've got 8 numbers in total, and on this list 7 doesn't appear, so the probability of picking a 7 is impossible. 0, in other words. Then for part B, on the probability scale below, we have to mark with a cross the probability that Kim picks a number greater than 5. Well, how many numbers are greater than 5? We've got 1, 2, 3, 4 of them out of 8. So we've got 4 out of 8, which would simplify to 1/2. So we mark with a cross this 1/2. Then for part C, we have to find the probability that Kim picks an even number. Well, how many even numbers do we have? We've got 1, 2, 3, 4, 5 of them. There are 5 even numbers out of 8. So the probability is 5/8. Question number 11. Sunita wants to make 35 picture frames. She needs 4 nails for each frame. Sunita has 3 boxes of nails. There are 48 nails in each box. Has Sunita got enough nails to make all 35 frames? Show how you get your answer. Well, what we can do is find out the number of nails needed. The number of nails needed, we have 35 times by 4, which is equal to 140. 140 nails are needed. Now we can find out how many nails she has. The number of nails available, we have 3 times by 48, and if we work this out we get 144. So the question is, has she got enough nails? Well, she has enough, and that's because the 144, which is the nails available, is greater than 140, the nails she needs. Question number 12, we have to write 60 meters as a fraction of 1000 meters. Well, we have 60 over 1000, and if we work this out, we end up with 3 over 50 as a fraction in its simplest form. So we have 3 over 50. Question number 13. The accurately drawn map shows the position of 3 points A, B and C in a field. We've got the scale, 1 centimeter represents 150 meters. Parveen walks in a straight line from A to B. She then walks in a straight line from B to C. Susan walks in a straight line from A to C. Parveen walks more meters than Susan. How many more? Well, what we'll do is we'll find out what AB is. So what we need to do is measure a length for AB. So it looks like AB is around 4.9 centimeters. So if we convert that into meters, we have to times by 150. So AB equals 4.9 times 150. So it turns out we get 735 meters. Then she walks from B to C. Now that is 3.9 centimeters. So BC is equal to 3.9 times 150. So if we work this out, that's 585 meters. So that's going from B to C. And so therefore, in total, we have 735 plus 585. It turns out we get 1,320 meters. Now, let's find out what AC is. AC is 6.9 centimeters. So I need to do 6.9 multiplied by 150. So that's 1,035 meters. So the difference between these is how much Parveen walks more than Susan. So we have 1,320 subtract 1,035. So if I work this out, we get 285. So we have 285 meters. Then for part B, we have to find a measurement, find by measuring the bearing of A from C. So we are at C and we want to go to A. So if I join A and C together, then we've got this. And to find out the angle, we can measure along, and it turns out we get 286. So the angle that was measured is 200. and 86 degrees. Question number 14. Here is the shoe size of each of 12 boys in a class. We have to find the median. First of all, you will find that the data is in order. So we can find the median by working out the 12 over 2, which is 6th value. So we've got 1, 2, 3, 4, 5, 6. The median then is 7. Then we have to work out the range. Well, that's equal to the biggest number, 9, subtract the smallest number, which is 4. The range is equal to 5. Then, for the shoe sizes of each of the 12 girls in the class, the median size is 6 and the range is 3. We have to compare the distribution of the shoe sizes of the boys with the distribution of the shoe sizes of the girls. Well, the median of the boys' shoe sizes is greater than the median of the girls' shoe sizes. That's the first thing we can comment on. And we also have the range of the boys' shoe sizes is greater than the range of the girls' shoe sizes. Question number 15, we have to work out 2.75 times 14.6 divided by 10 subtract 1.97. Well, what we can do is work out the value of this using our calculator. On our calculator, we have 2.75 multiplied by 14.6 divided by 10 subtract 1.97, and it turns out we get a value of 5. Question number 16. On the centimetre grid, we have to draw an isosceles triangle with an area of 12 centimetres squared. Well, it's an isosceles triangle, and what we want is to find out the height and also the base of the triangle. Now, to work out the area, we do base multiplied by height divided by 2, and this should equal 12 centimeters squared. Now, what we need to do is find two numbers such that when I multiply them together and then divide the answer by 2, I get 12. Now, if I multiply both sides by 2, we've got base times height equaling 24. So I need two numbers which multiply to give 24. For example, I could have 6 for the base and 4 for the height. So if I have a base of 6, then here is the base, rather, I've got the base, which is 6 over here, and then I've got the height, which is 4, which I need to draw on. So I want a height of 4. So when I come to draw my isosceles triangle, here is the base, and the height is 4, and therefore here is our isosceles triangle with an area of 12 centimeters squared. Question number 17. We have to expand 3 multiplied by 4 minus 2x. 3 times 4 is 12. 3 times negative 2x is negative 6x. For part B, we have to solve 3y divided by 4 equals 12. Well, if I multiply both sides of the equation by 4, then we have 3y, which is equal to 48. And then if I divide both sides of this equation by 3, we are left with y equals 48 divided by 3, which is 16. For part C, we have to factorise 4p plus 6. What's common to both the 4 and the 6? Well, that's 2. What's common to the p and the 0p? Well, that's nothing. So I've got 2 as my highest common factor, and then inside the bracket I would have 2p plus 3. Question number 18. For part A, we have to write 2,530 correct to 2 significant figures. Well, if I take a look at the third figure, which is this 3, that's less than 5, so we don't need to change this 5. So we have 2,500. Then for part B, we have to write 0.00874 correct to 1 significant figure. Well, the first significant figure is 8, the second one is the 7, and the third one is the 4. Now if I take a look at the second significant figure, that's 5 or greater, so this 8 needs to be moved up to the next digit, so we have 0.09. Question number 19. There are 400 counters in a box. The counters are red or yellow or green. 3/8 of the counters are red. 82 of the counters are yellow. What percentage of the counters are green? Well, let's find out the number of red counters. 3/8 of 400. Well, if I work this out on my calculator, that's 150. There are 150 red counters. For the number of yellow counters, well, we have 82 of them. So the number of green counters, we've got 400 in total. Subtract the 150, which is red. Subtract the 82, which is yellow. And it turns out we get 168. And what we need to do is find the percentage which is green. So we have 168 divided by 400 multiplied by 100. So it turns out we get 42%. 42% of the counters are green. Question number 20. In the diagram, PQR is an isosceles triangle with PQ equaling PR, and APR and CQD are parallel lines, and BPQ is a straight line. The angle APB is 56 degrees. We have to work out the size of the angle CQR. Give a reason for each stage of your working. Well, what we can do is find out this angle first, the angle QPR. And this angle here is equal to 56. So we have 56 degrees. Now, giving a reason for this, well, we have vertically opposite angles which are equal. Now we can find out what this angle is and also what this angle is. And the way we can do that is to recognize that the sum of the angles in a triangle add up to 180 and the base angles in an isosceles are equal. So the angle PQR, which is equal to PRQ, that's equal to 180 subtract 56 divided by 2. So if I work this out, we get 62 degrees. So we have 62 degrees here and 62 degrees here. So angles in a triangle sum to 180 and the base angles in an isosceles are equal. Now we need to find the angle CQR. Now for me to find out what CQR is, I need to find out what this angle here is. And for me to find out what that angle is, because I've got parallel lines, I can also find out what this angle here is. Now I've got a straight line, so I can find the angle APQ. The angle APQ is equal to 180 subtract the 56. And if I work this out, I get 124. So I've got 124 degrees, and the reason that this angle here is 124 is because angles on a straight line sum to 180. So if this angle here is 124 degrees, I can find out what the angle CQP is. So the angle CPQ, that's equal to 180 subtract the 124, which is equal to 56 degrees. So this angle here is 56 degrees, and that's because we've got co-interior angles. So we've got co-interior angles which sum to 180. And therefore, to find the angle CQR, CQR then is equal to the 56 plus the 62, which is equal to 118. So I've got 118 degrees. And that's exactly what I wanted to find out, because I've got this angle plus this angle. Question number 21. We have to work out the lowest common multiple of 24 and 56. Well, the 24, if I write that as the product of its prime factors, well, I type in 24 and then if I press Shift and then this button, that finds the factors. I get 2 times 2 times 2 times 3. And if we find the factors of 56, well, the prime factors of 56, we've got 2 times 2 times 2 times 7. So now we can find the lowest common multiple. We can do this by seeing that we've got a 2 which is common to both. Then we've got the 2 here which is common to both. Then we've got this 2 here which is common to both. And then we've got the 3 and the 7 which we need to multiply. So if we work this out, we have 8 times by 7 times by 3, which is 168. So the lowest common multiple is 168. Question number 22. Here is a right angled triangle, and what we have to do is work out the value of x. Well, if we use Pythagoras, we have x squared plus 4 squared equals 8.5 squared. X squared plus 16 is equal to, well here, if I work out what 8.5 squared is, that's 72.25. And now if I subtract 16 from both sides, what we have x squared is 56.25, and now to work out x, I would have to square root. So if I square root, I get 7.5. So I have x equals 7.5. Question number 23. T is equal to 4m squared subtract 11. We have to work out the value of t when m is negative 3. Well, when m is negative 3, t is equal to 4 multiplied by negative 3 squared subtract 11. So I've got 4, and then in brackets I've got negative 3, then squared, subtract 11, we get 25. Then for part B, we have to make p the subject of the formula d equals 3p plus 4. Well, if I have d equals 3p plus 4, we want to get p by itself. So if I subtract 4 from both sides, that means I've got 3p equals d subtract 4. And then if I divide both sides by 3, that would mean that p equals d minus 4 over 3. So in other words, p is equal to d minus 4 over 3. Question number 24. Rick, Selma and Tony are playing a game with counters. Rick has some counters. Selma has twice as many counters as Rick. Tony has 6 counters less than Selma. In total they have 54 counters. The number of counters Rick has to the number of counters Tony has is in the ratio 1 to p. We have to work out the value of p. So, in this question, what we will do is we will let x equal the number of counters Rick has. And if that's the case, then Selma has twice as many as Rick. So Selma has 2x counters, and Tony has 6 less than Selma. So Tony has 2x minus 6 counters. And we know that the total number of counters is 54. So I've got x plus 2x plus 2x minus 6 equals 54. 5x minus 6 equals 54. 5x is equal to 60, x is equal to 12. So that means Rick has 12, Selma has twice this, which is 24, Tony has 6 less than this, which is 18. Now we need to find the ratio of Rick to Tony. The ratio Rick to Tony, we have 12 to 18. And if I write this in the form 1 to p, well, I want a 1 over here, so I have to divide both sides by 12, which is 1.5. 18 divided by 12 is 1.5, so that means p is 1.5. Question number 25. Joe is going to buy 15 rolls of wallpaper. Here's some information about the cost of rolls of wallpaper from each of 2 shops. So with Check Deco, 3 rolls cost £36, and with Style Papers, a pack of 5 rolls, the normal price is £70, and we have 12% off the normal price. Now, Joe wants to buy 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from Chick Deco or from Style Papers? You must show how you get your answer. Well, what we can do is find out the cost for 5 rolls. If we have 12% off the normal price, then 12% off would correspond to a multiplier of 0.88. And if I multiply this by 70, the normal price is 70, we get 61.60. So 70 multiplied by 0.88, that's equal to 61.80, rather 61.60. That's the normal price. So if we think about Chick Deco, then what we have is 3 rolls, which equals £36. And what we want to do is find out the price of 15 rolls. So for 15 rolls, I have to multiply by 5. 36 times 5 is 180. So for 15 rolls, it cost £180 from Chick Deco. Now, with Style Papers, what we have for the price is 5 rolls, which equal £61 and 60 pence. We want to find the price of 15 rolls. So if I multiply by 3, we get 184.80. And so therefore, we can buy from Chick Deco, it's cheaper. Question number 26. The table gives information about the length in centimeters of some pieces of string, and Amos draws a frequency polygon for this information in the table. We have to write down 2 mistakes Amos has made. Well, first of all, we need to find the midpoints of each of these intervals. We've got 5, 15, 25, 35, and 45. So now what we have to do is check if these are plotted correctly. Now, if I take a look at the frequency table, straight away I can see I'm going from 0, 10, 20, 30, then 50, then 60. So the first thing that's wrong with this is 40 is missing from the frequency scale. So 40 is missing from the frequency scale. And the next thing I can spot, well, 50 has been plotted with 5. I should have plotted 45, 5. We are supposed to plot the midpoints of the intervals. So, an incorrect point 55 is mapped. It should be 45, 5. Question number 27. Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. We have to work out Amy's average speed. Give your answer in miles per hour. Well, here we've got minutes and here we've got hours. We need to make the units consistent. So if I've got minutes and hours, minutes to hours I divide by 60. Hours to minutes I multiply by 60. So what I can do first of all is find the total distance. To find the total distance, well, what I need to do is convert, first of all, this 15 minutes into hours by dividing by 60. So I've got 15 over 60 hours multiplied by the average speed, 6 miles per hour, so what we end up with, well, that's the first part of the journey, and then for the next part of the journey we've got 40 minutes, so I need to convert that into hours by dividing by 60, and then I need to times by 9 miles per hour. So I'll multiply by 9 miles per hour. So we can find out the total distance in miles. So if I work this out, 15 over 60 multiplied by 6 plus, so 15 over 60 times by 6 plus 40 over 60 times 9, which is 15 over 2, or 7.5 miles. So now I can find out the speed. Now I know for the final part it takes 45 minutes to run the same total distance that Jessica's run. So for her average speed, I've got the total distance, 7.5 miles, and then I'm going to divide this by the time, 45 over 60 hours. And so if we work this out, 7.5 divided by 40 over 60, rather 45 over 60, we get 10. So the average speed is 10 miles per hour. So we have 10 miles per hour. Question number 28. The diagram shows rectangle STUV, TQU and SRV are straight lines. All measurements are in centimeters. The area of the trapezium QUVR, the shaded one, is a centimeter squared. We have to show that A is equal to 2x squared plus 20x. Well, what I can do is find out this missing length over here. So we can find out this missing length. If I've got 3x plus 5 in total, I subtract 2x from it, leaving me with x plus 5 for the length of the side. So that's what the length is. And here the height is going to be 4x. Now to find out the area A, we've got the area of a trapezium, 1/2 times by the sum of the two parallel sides. So I've got the 5 plus the x plus 5, and then I'm going to times that by 4x. So if I work this out, well, 1/2 times 4x is 2x, and then inside the bracket I've got x plus 10. And if I expand out, I end up with 2x squared plus 20x. Question number 29. We have to change 300 meters per second to kilometers per hour. So first of all, to go from seconds to minutes to hours, well, seconds to minutes, I divide by 60. Minutes to hours, I divide by 60. Hours to minutes, I times by 60. Minutes to seconds, I times by 60. And to go from meters to kilometers, we divide by 1000. Kilometers to meters, we times by 1000. So if I have 30 meters per second, then if I divide this by 1000, 30 divided by 1000, that's 0.03. So we have 0.03 kilometers per second. Now I want to convert this kilometers per second into kilometers per hour. So to work this out, what I would have to do is divide the second by 60. So I've got 0.03 kilometers over 1/60 minutes. So if I do 0.03 divided by 1/60, this would convert it into kilometers per minute. So it turns out we get 1.8 kilometers per minute. And then what I need to do is divide this by 60. So I've got 1.8 kilometers over 1/60 hours. So I need to divide this value by 1/60, so I get 108 kilometers per hour. Question number 30. The value of Michelle's car has decreased by 15%. The car has a value of 13,600. We have to work out the value of Michelle's car before the decrease. What we'll do is we'll let x equal the original value of the car. So I've got my original, and I'm going to multiply this by the percentage multiplier, which is 0.85. So this 0.85 comes from decreasing by 15%, and the final value, once I've decreased it, is 13,600. So if I work this out, 13,600 divided by 0.85, that's 16,000. So the original price of the car is 16,000.